Okay, we're going to put in our mates. Now, we've already machined this on one side. We want to reference the faces on the model, not the stock, for our origin. And we also imported 1/4 inch parallels by default. Those look too deep, but we will make adjustments once we have the mates in place. Okay, so to do this, we are going to actually hide the stock for now. We'll come back and use that later, but we're going to go to the joint command, and we can use the default settings for our first joint if it's on the vise. Now, we want to pick the side of the parallel in this case because the method we need to use on the model is going to be needs to have that orientation. So make sure your target is oriented to the side plane of the parallel. That's our first selection for our rigid joint. And then we're going to zoom out and we're going to look at our model. Now we don't have a corner here we can pick on. It's a theoretical corner that is an intersection of the edge I have highlighted and the second edge I have highlighted. So what we need to do is we're going to change our selection type to 2-edge intersection so that we can select that. And it's going to pick the intersection in the same plane as these lines. That's why we needed the target on the parallel to pick up on the side view. So I'm going to pick the horizontal line on the bottom of the part and the vertical back edge where it would touch the vise jaw. And you notice the target is in the same plane is what I'm selecting. We hit OK and it should bring those together. And we're going to go ahead and hit accept as a rigid joint. Now you notice our part is sitting really low, and in order to cut this surface we're going to be cutting it with a ball cutter that has to roll past tangency, which is this edge. We don't want to cut into our steel jaw. So my initial estimate of what size parallel is off. So let's go ahead and adjust that configuration. So you notice we have our two instances of the vices with the labels of which parallel height is being used. We right click on the instance we brought in second, and we can go to switch configuration, and we're going to switch to the 1.5 inch tall parallels. And we'll hit OK, and that puts in the taller parallels, automatically shifts up our part because we associated our joint with the top of the parallel. Power of parametrics there. Okay. Now, if we look in side view, we can't really put the parallel in up against the face of the jaw like this. It's actually going to have to sit in the center of this flat edge. We're not going to bother modeling that, but from a setup standpoint, you need to make sure that your parallel is under this flat edge, or your part is going to sit wherever this corner hits this radius, and it'll be sitting too low. So you want to make sure you don't make that mistake from a setup standpoint. One way to keep from doing that is you could put a shorter parallel behind this and it'll space this parallel out, and that way it'll be probably in the right spot. But we want to make sure that we're supporting the part under the flat edges or our datum is moving around. Okay, now we just need to adjust this number based off the width. So we go to an inspect, pick on the face of the part, and the face of the back jaw. Our distance is 404 inches, 575. So we need to double click our dimension, hit close, double click our dimension, and we're going to subtract 4.575, and it should suck up the jaw to line up with the back. Okay. Now when we turn our stock back on, we're clamped on the finished part because that's what's machined up to that state, and what we're machining off the other side is going to be a mushroom cap that's the size of the stock we have modeled here. Now we're not holding on to a great deal of a flat here, so we're trying to give us, there's not a lot of room there, so we're just picking up on a little bit of the flat. So from a setup standpoint, you got to make sure everything's clean and aligned to get a good clamping edge there. That is our two setups. And now we're going to go over to the machining side. I'm going to go ahead, since we're done doing assemblies, I'm going to go ahead and hide my file pane to give myself more screen space. Also, something I kind of don't like, I don't like seeing these datum targets. They're handy when you're working on it, but go to Visual Style, and we're going to pick on objects that are visible. Let's deselect joints and joint origin and the joints themselves. We don't need to see those now that they're established. If you want to go back in and turn those back on, you can later. Okay, so now we're going to go to manufacture mode. And the setup I have displayed is operation 2, so I'm going to go back to our models, expand this out, and I'm going to hide the second instance of the device and show the first instance again. Okay, and it looks like I got my display is showing the objects for that model, and need to hide those again. Okay, so we're looking at the correct operation. We got our stock here. We're going to remove about 30 thousandths of material because that's what we accounted for on the top. And we're going to profile around the edge, which doesn't have a ton of material except for in these two corners. So we do want to use a pretty good size end mill so that it just wipes that corner out and we don't have to come back with extra routines and such. Okay, so, and we're going to cut down to approximately the bottom of the part, which should leave us some clearance on the vise. Again, when you do set up your vise stop, you're going to want to set it up so that it's touching about center on the stock as low as possible so that nothing can hit it. Actually, you're going to want it to hit along the flat edge of this part of the part as low as possible, and then you won't have to move it when you do the second side. If you put it right in the center, it's going to hit right where this pocket is on the second side. Alright, so we're going to do our setups. We're going to go do a new setup, and let's look at our menus here. We're not going to use model orientation. We're going to use z-axis plane and x-axis. Okay, so our z-axis is going to be the top of the part, and it should flip our origin so that z is pointed up, and then our x-axis is going to be an edge of the stock, or it could be the straight line on the part. We're going to select that, and we look at our origin. It should be pointed, x should be pointed to the right, z should be pointed up, and y away from us. If it's not, you need to play with these buttons here. Okay, now it's making this huge piece of stock around it. That's because on the second tab we need to set something. So let's go to stock, and instead of relative box, we're going to use from solid. And then we're going to select our solid. So this is where we need to expand the bodies of our model, and we're going to select our stock. Okay, and that should snap everything in orientation to where it matches our stock. Okay, now at this point we need to go back to our setup, and we're going to set our origin on this operation is going to be based off a stock box point. So let's select the box point. Now here's where you have your different orientation philosophies. So we, on this first op, it kind of doesn't matter on the first operation. We could set our origin here. We set all our tools to the part. Then we flip our part and we're going to have to make an adjustment for the height of each one of those tools. If we before we can run the second side, and there's an instance of error that can be created there. The other philosophy is, okay, if I set it here at the top of my parallels, as long as my origin is always on the top of my parallels, I don't need to make an adjustment based off my material size. Now we're going to be using a different set of parallels for Op2, so we're going to have to do a Z adjustment, but it allows us to do the adjustment once in the fixture offset. So if we base our origin here, the shift on our work offset would be the difference in the height of the parallels, not the difference of material that can vary in size. So I am going to go with that method. I'm going to pick the lower left corner of our stock, which is actually the top left corner of the parallel, as our origin. Okay, it's important when we make our setup sheets that you have a view that shows where that is, and that it's in the program notes. We're going to show you how to put a reference to what height parallels to use. Okay, we got all that set. Our stock should be good. It should match our Traveler, which was 6.6 long, 1.25 wide by 1 inch tall. We're going to go to post processor. Our program number is going to be the part number 7311, and for the first operation 1. Okay, that's going to be a consistent numbering. 5 characters is the limit for the Haas machine on part numbers. Our program comment is going to be op1, and then we're going to do WCS. We're going to put offset 1. That'll output on a Haas G54. Is it okay? And then we're going to change this setup to op1 to match, so we know what we're looking at. Okay, so what we're going to do is we're going to first mill down the top of this block. We're going to use a face mill for that. You could use an end mill, but you should download the library that's in the assignment. We're going to do a facing operation. We're going to select tool number 1 from our library, which should be the 3-inch diameter face mill. And at the time of this recording, the spindle speed was set too low on the default setting. So let's set this spindle speed at 3000, and we'll use that consistent with this cutter. And we will do an updated tool library on a semester basis. So if this doesn't default at 3000 RPM, change that. Okay. We're going to go to geometry. We're going to accept that it's the top of the part, which is fine. On our heights tab, now I'm getting an error. And the reason is I have the wrong model set as our part. So I realized I made a setup. So there's a teachable moment. If you run into this too and it's giving you an error here for stock top, you might have the wrong model selected. We're going to go back and fix that problem. Go back to the setup, go edit. On the very first tab, the model you select should be the part body. Okay, so that's for the model of the part you're making, and then the stock is based off the body for the stock. We're going to hit OK, and now we're going to start over. We're going to go to face mill. We're going to select our tool. We're going to use the 3-inch face mill. We're going to change our RPM to 3000. We're going to leave everything else at default. Go to geometry. We're going to select the top. Let it select the top of the part. On our heights tab, we're going to go from stock top. The feed height is going to be. So we're going to leave the top height at stock top, and the bottom height is going to be model top. So the difference is between this light blue plane and the dark blue plane is how much material is being removed. Okay, our pass direction, you can choose what direction you want the pass to go in. I believe it's going to default in the longest direction, but if it doesn't, you need to select that. Pass direction at 0 degrees. Pass extension, that's how much farther past the stock it's going to go. It defaults to half a diameter. That makes me a little bit nervous. I'm going to I don't want it to plunge in that, so I'm going to put 1.6 as our extension, just go a little bit farther. Our stock offset is if we wanted to even offset even further. Our step over right now is set at 2 inches and 566 thousandths. We're going to go in both directions. If we don't like what side it starts on, you can pick from the other side. We're just going to take the default here. We don't need to do any stock to leave or multiple depths. We're just skimming 30 thousandths off the top. Okay, our maximum stay down, we're going to leave all that at default. You do want to make sure this box that says keep tool down is selected. We got our lead in. We have a vertical lead in radius, which I'm going to set at 0. I don't know why we use that. And we got a lead in and lead out extensions. Our transition is going to do a smooth move, and I will hit OK. And we really just get one pass because our part is just wide enough for one thing, one pass. Okay, so we've got our first routine there. Okay, next we're going to cut around the outside perimeter. We're going to actually hide the stock volume that we had in there for the moment. That way we can select on the features of the models for this at this point. And we're going to go to, we're going to do a 2D contour. And we're going to select our 1/2 inch flat end mill for this. So we're going to pick from our aluminum library, VF1 aluminum library, the 1/2 inch end mill. And we're going to hit OK. And we're gonna profile this thing, and the default settings for feeds and speed should be pretty good. 5,054 inches a minute. Should have a ramp rate of 27 inches, about half. If it's not that, you'll need to update it to match this video. We're going to go to geometry, and to achieve the contour we want, we're going to pick a silhouette. So that picks the silhouette of the part, but if you notice, it also includes the center here. So we want to change our selection. It defaults to selecting all loops. We're going to change it to only outer loops, and then it'll ignore the whole. Okay, and then it'll take that silhouette, and I believe by default projects it down to the bottom of the actual model of the part. Okay, we're going to hit OK, and then we're going to go to the next tab. Our heights. We can now change this to model top for the retract height, and the top height is also model top. We don't need to cut the stock that was already machined off the top, so it drops everything down by about 30 thousandths in this case. Okay, so our the default selected contour is going to be the silhouette projected to the bottom of the model. Okay, so in a lot of cases, I will go a little bit deeper here to make sure we don't have any flash. But because we are going to have a ball cutter cutting those edges from the other side, I'm not going to worry about it for this. If we do have a little bit of flash, it'll be on the very end, and that's easy to deburr. Okay, we're going to go to passes. We're going to go leave everything at default except for the compensation is going to be on wear. We're going to keep most of this at default. As we go down, we're going to go down to the roughing passes, and we want to do a roughing pass around the outside, and we want one step over. Now as soon as I do that, this box up here, I'm not sure why, it's counterintuitive, pops up. So our end mill is going to do a rough cut, and then it's going to leave 50 thousandths for a finish cut. Let's change our finishing step over to 10 thousandths in that case. Okay. Okay, we're going to go to multiple depths. Okay, and we don't want to take this in 1-inch passes or 900 thousandths passes. We're going to do this in 1/4 inch passes, so 0.25. Okay, and we will do a finish pass on the bottom. We're going to leave that at default. And the reason for that is that not so much that we need a finish pass on the bottom. What it allows for is a spring pass, and that will allow our part to be any cutter flex will come out of it when it does that extra pass around the bottom. So that's one method of doing it. We are going to finish only at final depth because our end mill has enough width. We are going to rough the final, and we'll use even step downs. Okay, we're not going to leave any stock to leave because we're just doing a roughing and finishing in the same operation. So stock on islands, none of that's going to matter. So we can just delete the islands. Next tab, and we're going to the linking tab. Let's leave all this at default. Let's check the keep tool down box. That way it doesn't lift up between each pass. Our horizontal lead-in radius is fine at 50 thou. We're coming in at a 90-degree angle, it's just fine. Linear lead-in distance of 50 thousandths is fine. I'm going to delete the vertical lead-in radius. I don't believe in them. We might want to select our start point. So we want it to start machining where the operator can see where it's starting to cut. Also, if we start on a radius, it helps with the blending. We're going to do our preferred lead-in position. Let's do it on the right side of the part. So you only want one selection point. I actually accidentally put in 2. We'll put it right about there. Let's hit OK. Alright, and you should get 3 rough cuts, and at the bottom we get a rough and a finish cut. And our end mill is big enough that you can tell by center line that it's past the corner, so we won't be left with corner material here.